And now let's come to our last topic. So in previous sessions, we have started learning about SuperMap iDesktopX from the basic knowledge and operations about it, and then to the tools for processing, and that for the tools and the applications for processing, for data processing and spatial analysis, and demonstrate them and practice those skills with detailed demos. And later we have learned the traditional skills for cartography, and as well as advanced application of digital map and geoprocessing automation model. And so today, for the last session, of SuperMap GIS training cap for 2022, our topic is to integrate video with GIS, and that is a very new feature of our software. And here we would here, due to the limitation of time, so we would only give you a basic introduction to this kind of knowledge and skill. If you are really interested, you can email us for more details. So now let's get started. So as always, this session will be divided into 3 parts. So first, we will have a general introduction on the integration of video and GIS. First, we need to know what is exactly what is the exact meaning of the integration of GIS, of video and GIS, and how can we apply them in our real GIS project. And as you can imagine, actually the integration of video and GIS involves a lot of technology and products. So we can use them either on our PC or through our mobile phones. And actually it also might involve the technology for AR as well. But here, as our topic is about SuperMap iDesktopX, so in this webinar, we would only focus on the application and integration of video and GIS in the desktop software. And so in the second part, we will focus on the integration of video and GIS in SuperMap iDesktopX, that is to say the application of video map. So here we would talk about how we can assign spatial coordinates to video file, and how we can create a video map in desktop software. And then in the third part, we would use 2 demos to show the basic operations of video map in SuperMap iDesktopX, including how to assign coordinate systems to it and how to extract basic spatial information from video. And now let's get started. So first, let's have a general introduction on the integration of video and GIS. So here, as we can see, in traditional GIS, no matter what kind of data you are using, eventually you have to assign a coordinate system for them so that they can be they can be used in GIS in a GIS system, and that rule is also can be applied to video as well. So our first step and the key for the integration of video and GIS is to unify the coordinate system of video and GIS. And After that, then we can find, and after that, as we have assigned coordinate systems to our video file, then we can use that video file to extract spatial information. Especially if we are using streaming video data, then we can get real-time spatial information from the video file. And then we can combine such kind of information with our traditional static GIS data. And then we can combine them together for further spatial analysis and extract useful information to be used and shown through GIS system. And so now here we would have a quick introduction on techniques involved in the integration of video and GIS. So as we have said before, the first step of integration, the first step to integrate video and GIS is to import video. And once we import video into GIS system, then here are two things we can do. The first one is the most basic one, that is to create a video map after we assign correct coordinate systems to the video file. Or if we have AI tools, then we can let AI help us to conduct tasks like feature recognition in video file. And either way, we can and after we recognize those features from the video file, then we can still assign coordinate systems to it, and then show that, and then create spatial features from that result and show them in our video map. And either way, we can finally integrate all the information we have extracted from video into a GIS application system. And so that is the general procedure of GIS. That is the general procedure of GIS and video and GIS application. And so here we would see some application examples of the integration of video and GIS. So usually, if we want to use video and GIS, if we want to conduct, so really, when we want to use when we want to combine real-time data with our traditional spatial information, then we can apply video and GIS in our project. And usually we would use this kind of technology in for smart city project, so that we can get the real-time information of the city from our surveillance cameras, or we can also get some data from real-time transportation data, and then to create a transportation monitoring system using the technology of video plus GIS. And when there are some hazards happened, we could also use video plus GIS in emergency management as well. And now let's see some examples of such application. So here, the first thing we need to know is what kind of video data we can import it into our GIS system. And so here, in SuperMap products, actually we support data from various surveillance cameras or the video or video recorded by drone camera, or we can directly import local data file. And the most convenient one is that we can the most convenient method is to simply record a video using your smartphone camera, and we can also import that into GIS system. Like here, you can see on the right. And so here are some examples of GIS. So here are some examples of video plus GIS in desktop software. So here, the first one is an example of, and here the first one is an example of object detection. So here we can see that we have imported a video into our desktop software, and on the right is the original data, is the original video, and on the left we can see that here we have recognized each of those. Sorry. So here, let's see this example again. First, we can import this original video into our desktop software. And then if we have AI tools, then we can use AI then here we can use AI to recognize features from the video. Like here on the right is the original video file, and on the left here you can see that we have those blue rectangle that is to show each of the car features on the video, and the car is moving. Those rectangles are moving as well. And another application in desktop software is that here we have a surveillance camera, and here we can see that we directly digitize those parking lots on the video, and once we draw them on the video, we can see that our digitizing result is shown as vector files as well, so that you can see that as we add a parking lot on the left, then they are also shown in the, on the right. And not only can we add those vector features, we can also add texts as well. And then here, the last example is that once we get the spatial information of this video file, then we can use that to track the route of the video device and show it, and immediately show it on the right here, as you can see on this map. And so here I see that here's a question about what does AI mean. Here, AI means artificial intelligence. And in our first example, as we just showed here, as a first example we have just shown here, we can use AI or artificial intelligence to recognize those car features, all those car features on this video. And that's a very simple application of AI. And here, if we are using mobile apps, then we can also combine video and GIS together. Like in this example, we find some trash on the road, and we can use our mobile app to scan it, and then it can automatically recognize, oh, here is the trash, and it can record its location and the time we found it, and submit to those managers so that they can clean up the road immediately. And here is a more complicated video plus GIS system example. And this one also use AI as well. So here we would have a further explanation on it. So here, first we would use some sample data, that is the image of cars and trunk, and then we would build an AI model or machine learning model and train that model using those sample data, so that the model can automatically recognize car and trunk feature from the video. And so once we have set up our surveillance camera to an interested area, and then we can combine that video with the model and GIS system, and it can automatically recognize cars and trunk appear in this video. And now let's go back to our desktop software. And in desktop software, the application of video plus GIS are really applied in the way of video map. So here, let's first see the definition of video map. So in desktop GIS software, in desktop GIS software, the base for video map is this. The base for video map application is the spatialization of video, and that is to say, as we said before, assign correct coordinate systems to the video file. And once we complete that step, then we can combine our spatialized video. We can process those spatialized video with computer visualization or AI technologies, so that we can get real-time spatial information from the video, and also conduct some smart analysis like object detection. And here are some basic characteristics of video map. So the first one is about the coordinates of video map, because we're living in a 3D world. So for video map, actually it is a 3D. So actually, when we are using video map, we're creating a 3D space as well. So here should be 3 coordinates for it. Here we should set 3 coordinates for it: X, Y, and Z. And here Z means the height of the feature. And if we are using streaming video, then we can get real-time data. But on the other hand, if we're simply using a local data file, then the information we extracted are not real-time information, but that would be relative. But on the other hand, that is but either way, either way, the appearance of video map should be the appearance of our real world. So that could be more vivid than our traditional map. And also, as we're shown the real world in our video map. So here we can extract more diverse information from the video map. And so here, let's talk about some details about video map. So the first one is what kind of video format can be imported into SuperMap iDesktopX. So here, there are two kind of videos we can import it into our desktop software. So first, we can simply import our local video file, either it's MP4 or AVI or FLIC or FLV, and stream video is also supported, but it would be more complex for us to import it into our desktop software. So really, there are two ways to import stream video. So the first one is to upload it to some stream server, and then we can connect the stream server with our desktop software and import stream video into the software. Or we can use SuperMap iMobile app, or we can use SuperMap iMobile app to take videos. And so that kind of video can be directly imported into SuperMap iDesktopX as well. And for today's session, we would only learn the most simple. So for today's session, we would learn a simpler way to import video into SuperMap iDesktopX. So here we would only use local video file in our demos. And then once we imported video into our desktop software, the next step is to assign coordinate system to the video, or in other words, the spatialization of video. And here in SuperMap iDesktopX, we have provided with two kind of algorithms to assign coordinate systems to video file. So the first one is 2D homography, and the second one is pinhole camera model. And here, really we would recommend you to use 2D homography because it only requires 4 pairs of control points, and it has a higher efficiency as well. But if you have your camera parameters, then you can switch to pinhole camera model methods as well. And here are some limitations for this kind of method. Because it can only apply to projected coordinate system, and it also asks projected coordinate systems. So if you are using geographic coordinate systems, then you'd better to transform your coordinate systems first, and then use pinhole camera model to register your video file. And so here, as we have learned the algorithms, so actually there are 2 ways to assign spatial. Previously, what we said is about the algorithms. In other words, the mathematical algorithms to assign spatial to assign coordinate systems to our video file, and then in our software, actually we have two methods to conduct such spatialization. Here are two conditions you can see. The first one is if you have camera parameters, then that's the most simple condition. In this way, you only need to import your CSV file, the CSV file of your camera parameters, and then choose either of the and then just simply use here our second algorithms to conduct the mathematical calculation, and then the software can import and then the software can assign the coordinate system for your video data. But really, you can only get the CSV file of your camera parameters if you are using drone video. If you are, in other cases, if you are simply use your own camera or your own mobile phone to take a video, and then for such kind of video, you can't get the exact or precise camera parameters. And in that case, here we have another solution to assign coordinate systems to such kind of video file, and that is interactive registration, which is actually very similar to registration we have conduct for our traditional spatial data set. For our traditional spatial data, that is to say, you have to find a reference map first, and then to create your and then to pick several pairs of your control points, and then you can conduct the registration. And so here, if you're using interactive registration, still there are two cases, because when we are taking videos, really you won't stand here. Really, your camera is moving, and in that case, you have to conduct registration for each you have to conduct registration for multiple frames as long as your camera is moving, so that the software can know exactly the location of your camera. In other case, if you never moved your camera, or that is to say, the location of your camera is static, then you only need to conduct registration for one frame, and you only need to conduct the registration for one frame. And later, we would conduct such registration, and that would give you a more clear understanding for what you need to do for different cases. And so here we have some examples to show the abilities of video map. So the first one is a very simple one, that is to extract spatial information from video, and as well as combine our traditional spatial information with video. Like here, you can see that we have add two spatial data layer into our video, and that can show the categories of each of the building, and also the name of each of the buildings. And then once we imported our video into our desktop software, then here are some effect in here. We can count some effect enhancement. Like here, you can see now what we can see is the original video. And if you want to add some effect to the video, like here, you can add the effect of snow or rain to the video as well, so that it could look more vivid and interesting. And here, the next ability is that we can also integrate our video with oblique photography model, so it would look more like our real world. So here you can see that actually this is seen combined with images here, as you can see in the surroundings, the images and oblique photography, like the road and the tree in the center, and then also the videos that is showing the moving of those cars. So here, as you can see, how we combined those three kinds of data together and show them in one scene. And this is the application in 3D data. This is actually a new feature in 3D application. And also, as we have AI tools in iDesktopX, then we can also conduct object recognition and analysis. Here is another example of AI object analysis. Like here, we have a video showing the road. We have a video showing cars on the roads, and then we can draw the track of each of the cars on the roads. Or here we can set a forbidden area on the road, and then we can recognize whether there are some cars that enter this forbidden area. If so, we can record the type of the car and then inform the owner of the car if necessary. And so that's all. Oh, sorry. And here's one thing to be clarified. Although although we have a lot of great abilities for video map, but here if you are only using SuperMap iDesktopX, maybe you cannot get full abilities for like object analysis, the integration with oblique photography model, or effect enhancement. If you want to try or experience those abilities, then you have to download a AI package, because all of those abilities then here what you can do is to extract and combine spatial information with your video. And so here, let's move to our last part. That is about some basic operation of video map in SuperMap iDesktopX. And here, our first demo is to simply create a video map in our desktop software and import a local video into that video map, and then assign a coordinate system to it based on our reference map. And so here we have a list of the data we're using for this demo. So first, we have a data source that contains the reference map for file that is our original video file. We would import it into our software. And finally, we have a file that records our control. Here is the steps for spatialization of video. First, we need to create a new video map. Once we create a new video map, then we can add or import videos into the software. If there's no video map created, then you can't find the entrance or the function to import a video into our GIS desktop software. And then once we have a video map, we can import video into it. And the last step is to using interactive registration to assign video maps, to assign coordinate systems to that video map. And here, as we said before, if our camera is moving, then we need to conduct registration on multiple frames. If the camera is static, then we only need to conduct registration for one frame. And here I can show you that for this demo, our video is the camera recording the video is moving, so that we need to conduct registration for multiple frames. And so now let's take a 5-minute break. And during that break, you can open SuperMap iDesktopX and explore the data or material we just provided to you. And if you have some questions, you can also raise them in the chatting box. After 5 minutes, we will do the demo together. Okay, now time's up for the break. Now, let's come back to our demo. So first, please open up SuperMap iDesktopX. And then here, I would lead you to see the materials for today's session. Here under the folder called 08, you can see that first one is the slides for today's session, and then the XML file is the control point file we are going to use later. And then here you can see this OV building is the original file, video file, and we would import it into SuperMap iDesktopX. And here, the data. Sorry, wait a second. Okay, here, the data source called video GIS contains the reference data set, contains the reference map we're going to use for the spatialization of video, and also some features in the same study area. And so now let's go to SuperMap iDesktopX. The first thing we need to do is to connect to our data source. So as what we always do, go to Workspace Manager, and select the data source. Right-click, then choose Open File Data Source, and here choose Video GIS and click Open. And under Video GIS, here we can see that those T17 map is a reference map we're going to use later. And here buildings contains some features in the same study area. And now the first thing we need to do is to import the video into SuperMap iDesktopX. And that's different from what we usually do when we want to import traditional spatial data into the software. Here, you can try like as we usually do, we can select a data source and right-click and then choose Import Dataset. And then click the End button and click the End File button on the left. And here we can see that if we navigate to 08 folder, here we can only see the control point file, but we cannot see the MP4 file. And if we check the supported file type and scroll down here, you can see that there is no video type file that is supported here in data import. So we cannot import video into SuperMap iDesktopX as we import other data into the software. So here, to do so, the first thing is to create a video map. And there are two ways to create a new video map. The first one is to go to the Start tab on the top, and then under Browse, we can find that here is a button that is called Video Map. You can simply click on it and to create a new video map. Or you can go to Space Management, and under it, Workspace Management. Then you can go to Workspace Manager, and then scroll down. Under it, you can see that here is a type that is called Video Map. You can right-click on it and choose to create a video map window. Either way is okay. So here, I will simply click on Video Map under Start tab. And now we have created, and now you can see that here is an unnamed video map. And now we can import video into it. Here, still, we cannot import it directly to our we cannot import it directly from the data import connected with our data source. To import a video here, we must go up and find a tab that is called Video Map. And under Video Map, on the very left, you can see that here are two buttons. The first one is Local Video, that is used to import local video file. And if you want to import streaming video, then you can choose Online Video as well. And so here, as we only have a local map, as we only have a local video file. So here, simply click on Local Video. And then on the top right, on the top left, we have an Add button. Click on it. And now let's still move to the folder of 08. And now you can see that here we can select, we can see the local MP4 file that is our video map. And also you can go to File Type to see here is the list of all the of all the local video file that is supported, or the local video file type that is that are supported by SuperMap iDesktopX. Now here, select that video file and click Open. And here, once we add here, you can see that that is a video we're going to import it into the software, and it would be added into our data source. And here we would use the data source that is called video GIS. And also we can assign a name for the new data set. So here we would call it building video. And click OK. And now, actually, you can see from the layer manager, you can see that we already added the video into the software. Here, if your screen looks just looks as mine, if it looks blank, then simply click on this unnamed video on the tab of the unnamed video map to refresh it. And so now you can see that once I click on it, then here I can see the video in this map, in this window. And at the bottom of this window here, we can see that here are play controls for the video. Like if we click play, now you can see that here the camera of this video is moving. So when we conduct registration, we need to conduct that for multiple frames. And here we can pause it now. And now, before we conduct video registration, first here, we can see that under our data source, we can see that we already add a video map, we already add a video file into this data source. And here we can select this video data set and right click on it to check its properties. And here on the right, we can see that here are some information for the data set and here we can see that there's no coordinate system assigned to this video map. So our next step, we need to conduct video registration to assign correct coordinate system to it. And here, as we said before, T17 is the reference map we're using for the registration. If we click on it here first, we can see that we can see the coordinate system it's using, and also we can double click to open this data set and to see how it looks like. Here, if we go back to our video map, here you can see that here those several buildings are our main study area, or where we are focusing on. And we can see from this video that it's directly it is beside a road. And if we go back to our reference map here, actually here these several buildings beside this road is where we have taken this video. And so we can use this reference map to register here to register this video. And so here to conduct this video registration, that is quite simple. Here, still under the tab, under Video Map tab, here we can see that there is a group that is called Video Registration. Now we are under Browse Model, so we can conduct. And if we want to conduct registration, simply click on registration mode. And now you can see that the interface changed and the software asked us to provide a reference map. So here, click on this Add button, and we can use this T17 map as our reference map and click OK, then click Next. And now you can see that this interface is very similar to here, this interface is very similar to our traditional registration interface. So here, simply as what we did in registration, simply we need to pick our control points from the video and from our reference map, and then the software can conduct registration. And as we said before, here we have two registration algorithms. And if you want to change the algorithms, here simply go to Collaborate. And here you can see that here are two algorithms you can choose from, 2D homography or pinhole camera model. Here we would simply use 2D homography so that we only need to choose 4 pairs for each of the frames. And now here, as you can see, we have paused this video. And so now it is under the frame of the first second. And now we can pick the control points. And as the rules and the rules to pick those control points are very similar to our traditional control points. That is to say, really, we would use very clear features on buildings or roads as our control points. So here, first we can use the wheel on the mouse to zoom in. And then here in Video Map, the location of the control points is highlighted with this very small red little dot. So here I will choose this corner of the building. And then I will also zoom in to our reference map and choose the same corner of the building. So that is the first pair of our control points. Then we can zoom out, and then here zoom to another building. And choose the same control points in the reference map. So here, the algorithms only asked us to provide 4 pairs of control points. So it's quite easy. Oops. Now I have put a round location for the control points on the reference map. So here we can go to collaboration, and here we can switch from pick to modify. And then here you can see that we can change the location of this control point. And under it, you can see all the detailed information for each of the control point, for each pair of the control points. And then here on the right, we can close the window for properties. And here you can see that under the tab of video layer properties, here as we have here we have added control points for the first second of this video. And here you can see the records under video parameters. And then, as we said before, because the location of the camera is moving, so that we need to conduct registration for each, so that we need to conduct registration for multiple frames. And the more frames we have, the more precise the final registration result we can get. And to do so, first we can play the video here a little. Now it has moved to the third. It has moved to the third second of the video. And now you can see that all the control points we just set, we just picked, have disappeared because the location of the video has changed. And now we can pause the video, and then on the right, in the window of video layer properties, here under video parameters, we can click on add button. And now here, that means now the control points we're adding in this video map window is the control points for the third second of this video. And so now, as what we did before, we can zoom in to pick each of those control points. Oh, sorry. Remember to switch back to pick, switch back to pick model. And here, now, really, if you are doing it by your, doing the registration by yourself, then we would recommend you to add control points for each of the second, so that you can get a relatively precise registration result. But here, because we don't have that much time in today's session, so I have exported my control points, and now you can directly import them to get the results. So to do so, still we need to go to the right and go to video properties here, and then we can find the third button under video parameters that is called import. If we click on it, and now you can see that, go to where we have the materials for today's session. And here we have a XML file that is called CP, the short for control points. If we choose this one and click open, you can see now immediately it has immediately now we have added 30 control points for us. We have added control points for 30 frames of this video. But you can see that actually this video lasts for 1 minute. So if you want to get a more precise result, we would recommend you to the registration result have at least the control points to pick control points for at least 80 frames. But now it's okay to use the data we provided for you. And now as we have imported them, and here we can go back to the top, and under video registration tab, here is a save button. We can directly click on save. Once we click on save, then it would use all the control points picked by us by ourselves and or imported from read that control points file to register the video data set. And now we can switch back to browse mode. And then here, if we go back to our data source and select the data set called building video, and then right click to check its properties. And then go to coordinate systems. And now you can see that here we have successfully assigned the coordinate system of T17 map. Here, the APS code, the APS-G code for 3857 to this video data set. And now we can still play this video. Now maybe you cannot see much differences from before registration and after registration here. But now here you can see that here we also have a data set that is called buildings. Here we can double click on it to open it. And you can see that actually it contains polygon features to show buildings in the study area. And then here, sorry, wait a second. Okay. Now let's say, as we just now here, as we just assigned coordinate system to this video data set, as you can check from its property. And now we can assign, now we can add this original, this traditional spatial data set into this video map as well. Like if we right click on it and then choose to add to current video map. And now here you can see that it can almostly overlay with the buildings on this video because they are using the same coordinate system. And now, if we play this video, here, like if we play this video, now we can see that here those features in our traditional spatial data set still can overlay with those buildings on the video, so that can show the result of video registration. And here, now we can make this under layer manager. We can also make this feature layer invisible for a while. And now we can add some new features. We can digitize some new features from this video. Like if we zoom in, we can see that on the roof of the buildings, on the roof of some of the buildings, here we can find some air conditioner machines on this on the roof. And so this is a new feature we can extract from this video. And to digitize them, here we need to first create a new data set for this feature. So we can go to Video GIS and right click. Here choose new data set. And here for its type, we will change it to region and set its name. Like here, we would call it roof conditioner. And for the settings here, we need to change the settings for its coordinate systems. So here, we can go to more and enter the APSG code that is 3857. And double click on it. And then click OK. So that this new data set would use the same coordinate system as the video data set. And now we can right click on it and add it to current video map. And now you can see that there's nothing added to the video map because now we don't have any records in this new data set. And so here, under Layer Manager, here we can click on this small pencil button to make it blue. That means we're going to make the data set of roof conditioner to be editable. And then on the very top, here we can go to Start. Sorry. Okay, let's go back to our slides to find the reference. So here we need to go to the tab of video map, because now we're digitizing features from the video map. And then under it, here we can see on the very right, here is a small button or group that is called CAD objects. And now we can click on polygon. And then you can see that the mouse is switched to a very small cross. That means now we can digitize features on this video data set. So here we can zoom in to this roof with air conditioners. So here, simply follow the shape of those air conditioner features. And now, once we complete the digitizing of this group of features, simply right-click on your mouse. And now you can see we have added a polygon represent this group of air conditioner on this roof. And then we can move to another roof. And here, still, we can draw a small region to represent air conditioners on this roof. And once complete, right-click on your mouse. Now we've added another roof here, another feature here. And then we can move to this one. Digitize it and then right-click. Now we have added 3 features to represent air conditioners on 3 roofs. And now we can go back to Layer Manager, click on this small pencil icon, so that now we have saved our digitizing result. And here, go to our data set and find roof conditioner. Double click on it. Now we can open it, and then we can add building features to the same map window and simply change the order. And now we can see that here we can zoom out a little, and we can see here, if we want to show them in 2D format, now we can easily combine our digitized feature from this video with our original data spatial data set as well. And now let's move back to our video map here. So now we can make the layer of roof conditioner invisible. Our next step is, as we have added those building features into this video map. Now, as we can create semantic layer in our traditional map, we can also create semantic layer in the video map to show more information or to add more information to this map, to this video map. To do so, we still need to go to Layer Manager and then right-click on Buildings. And here you can see that here is an option called Semantic Mapping. Click on it. And here we are going to create a unique value map, a unique value semantic map. Click OK. And so here on the right, you can see the interface is very similar to the semantic map, to the semantic layer interface when we are creating traditional maps. And so here, under unique value expression, now we're using the name of the building as the unique value. Here, we can switch to the last one. That one is you can see that from its unique value, that is actually the record of the year. The building was built, so that it can add more information to this video map. We can combine this video map of this semantic layer, and then by one glance we can know which of the buildings are built in the same year. And then also, if we want to show their names, then we can still select the building layer and right-click, choosing semantic mapping. And now we can add label. We are going to create a label layer. Click OK. And now here, also, we can set the expression to the columns for the year of each of the for the built year for each of the building, or to show the name of each of the building. Either way is okay. And then once we click play on the video, so here, because I'm using Zoom Live, I'm using Zoom Live as at the same time, so it would take longer for the computer. Oh, sorry. Now it collapsed. It's not wrong. It's not because the software. That's because I'm opening too much software on the computer, so it's easier for it to collapse. But it will be okay on your own computer, and you can try to play your video with all the semantic layers. And if you have questions on the registration of video file, or add and digitize spatial information to the video map, you can raise them in the chatting box. And also, you can refer back. To our slides to show each steps we have conduct in today's demo. Actually, our first demo is simply registration about the registration of the video map, and our first demo, as was what we did before, is to extract spatial information from the video map and add semantic layers into the video map. And that's all for our last session. And now you can scan on this QR code to complete the quiz for this week. And as always, you would have 6 days to or almost a week to complete this quiz. And although we don't have sessions in next week, but next week, for those who are eligible for the certification, we would send you your certificate. And if you have questions about the certificate or your scores for each of the quiz, you can reach out to us through the email as well. And that's all for the training cap. Thank you for all of you to spend 2 months for this training cap. Okay, thank you all.